Hello, my name is Allie, and I am the SI instructor for Chem 140 at Cal State Long Beach. Chem 140 is chemistry for nursing majors, so if you're not in this course, even if you're in this course at another school, I wouldn't recommend watching this video because the rules they learn are slightly modified, and it may be confusing otherwise. However, if you are a Chem 140 student, this will be very helpful for you because these rules are hard to find on the internet elsewhere. Today we're going to be talking about ethers. So let's go ahead and talk about ethers. An ether looks like this in general. The formula COC. The way I remember ethers, because I don't want to be confused with esters, which look very similar. This is an ether, and an ester looks like this. It looks like an ether, but there's a carbonyl. There's a C double bonded to an O instead of just a C. The way that I remember the two is like this. Like, what are you drawing? That's weird. I'm not the best artist, so pardon me. I'm a scientist, not an artist. What are these? They're ether bunnies. Get it? Ether bunnies? Sounds like Easter. This looks like Easter, but you do not make the E a long E like that. It's a short E. So these are ether bunnies. This is an ester. Okay? Now, with ethers, in Chem 140, you're only going to be doing common nomenclature, and ethers are pretty easy. Ethers, we don't even really talk about properties of ethers. We don't even discuss any reactions with ethers, so all you need to know is how to name them, and it's pretty simple. So if I have an ether, the simplest ether would look like this. And this would be dimethyl ether. How you name it is you name the groups on either side. Since there are two methyl groups, then you say di. If we add something like this, go ahead and try this one on your own and see if you can figure this one out. I'll let you pause the video to do that. Now that you've tried this problem on your own, that's a methyl group, and this is an ethyl group, but you always want to name them alphabetically, or you want to order them alphabetically rather. So this would be ethyl methyl ether. Ethyl methyl, and we tack on the word ether. They don't really get too much complicated than this, too much more complicated. If we name this guy up here, what would this be? This has 1, 2, 3, and this just has 1. So this would be methyl because of this guy. And this group here is a propyl. And it's ether. So you shove the two words together, and then you tack ether at the end. Now, while we have the chance to do this, because this is pretty simple, let's go ahead and talk about other kinds of groups. In your class, you talk about different kinds of common names for substituents. So this here, what kind of group is this? This is a sec-butyl group. So this is sec-butyl, and this is isopropyl. Now, in reality, you don't look at iso and sec when ordering them. So this would be sec-butyl. We can put the sec in parentheses. It's really italicized. We can say sec-butyl isopropyl, and you can put that. It really doesn't matter for your class. You don't have to put parentheses. You can just say sec-butyl isopropyl and then ether. So you can do it this way if you're going by these groups here, because butyl comes before propyl. But you're also allowed to do it the other way too, because you're allowed to name them, or you're allowed to order them alphabetically by sec and iso, even though technically that's not correct in the real world. You're allowed to do that. So you can also say isopropyl sec-butyl as well. And that's pretty much it. It doesn't really get more complicated than that, except for adding chains and substituents and whatnot. And he won't give you anything too complicated with that. These are pretty simple. He's not gonna give you anything like, well, why don't we go ahead and do one more? Why don't we go ahead and do something like this and let's go ahead and do this. Why don't you try to name this on your own? Let's look at each group separately for easier purposes. I'm going to make this side green. I'll do that. So if we name this part, the O is attached onto carbon 2. It would be 2 pentyl. Carbon 1, 2, 3, 4, 5. Here, there's a substituent. The O is on carbon 1, so unless otherwise stated, you're just going to assume it's on carbon 1. And so this is carbon 1, 2, 3, 4, 5. So we're going to say 3 bromo 1, 2, 3, 4, 5 pentyl, 2 pentyl ether. Check that off the page. So again, you're just going to assume, you have to assume that the oxygen is on carbon number 1 here, if it's not stated. And that's how you do it. And it's similar to naming amines in IUPAC. So there's another video on that too.